A decade ago, JavaScript had a reputation that few developers admired. It was often described as a language for simple website interactions, adding buttons, animations, or basic form validation. Serious software, people believed, belonged to languages like Java, C++, or Python. Fast forward to today, and that perception has completely changed. JavaScript is no longer just powering websites. It's driving cloud platforms, AI applications, desktop software, mobile apps, and some of the world's largest online services. Even more surprising, the biggest innovation isn't the language itself. It's the new generation of web runtimes redefining how JavaScript is executed. These modern runtimes are making applications faster, more secure, and significantly more efficient than ever before. This transformation is so significant that many developers now refer to it as the JavaScript Renaissance. But how did a scripting language created in just 10 days become one of the most important technologies in modern computing? And why are companies investing heavily in entirely new ways of running it? The story begins with the browser. When JavaScript first appeared in the mid-1990s, its purpose was simple: make websites interactive. Instead of loading a new page every time someone clicked a button, JavaScript allowed web pages to respond instantly. At the time, no one expected it to become the foundation of modern software development. As the internet expanded, websites became more complex. Interactive maps, online shopping, video streaming, social media, and cloud applications demanded far more performance than early browsers were designed to provide. Everything changed when modern JavaScript engines arrived. Instead of interpreting code one line at a time, these engines introduced advanced optimization techniques such as just-in-time compilation, allowing JavaScript to execute dramatically faster. Suddenly, developers could build applications inside a browser that felt almost as responsive as traditional desktop software. The next breakthrough came with server-side JavaScript. For years, JavaScript only ran inside web browsers. Then developers gained the ability to run it directly on servers, allowing the same language to power both the front end and the back end of an application. This simplified development, reduced context switching, and accelerated the growth of full-stack JavaScript. Soon, an enormous ecosystem of open-source libraries and frameworks emerged. Developers no longer had to build every feature from scratch. They could reuse existing tools for databases, authentication, networking, testing, user interfaces, and cloud deployment. This ecosystem became one of JavaScript's greatest strengths, enabling startups and large enterprises alike to build software faster than ever before. But software continued evolving. Applications became larger. Cloud computing became mainstream. Artificial intelligence demanded greater performance. Edge computing pushed software closer to users. Traditional JavaScript runtimes, while incredibly successful, began facing new challenges. Startup times, memory usage, security, and scalability became increasingly important as developers deployed applications across global cloud infrastructure. This demand gave rise to a new generation of JavaScript runtimes. Unlike earlier environments, modern runtimes are designed specifically for today's computing landscape. They prioritize faster startup speeds, lower memory consumption, improved security, built-in developer tools, and better support for distributed cloud applications. Some are optimized for serverless computing, where applications start almost instantly to handle individual requests before shutting down again. Others focus on edge computing, allowing code to run closer to users around the world, reducing latency and improving responsiveness. The result is a dramatically different development experience. Instead of spending time configuring countless external tools, developers increasingly receive built-in support for testing, formatting, package management, and deployment. This simplifies projects while reducing unnecessary complexity. Performance is another major reason these runtimes are attracting attention. Many newer environments leverage highly optimized system architectures that execute JavaScript more efficiently, reducing startup delays and improving application responsiveness. While performance varies depending on the workload, modern runtimes are pushing developers to rethink what's possible with web technologies. Security has also become a central focus. Modern applications frequently interact with sensitive user data, cloud services, financial transactions, and enterprise infrastructure. New runtimes introduce permission-based security models, giving developers greater control over which files, networks, or system resources an application can access. Rather than granting unlimited permissions by default, software receives only the access it actually needs. This approach helps reduce security risks while encouraging better software design. Artificial intelligence is influencing JavaScript's evolution as well. Developers are increasingly building AI-powered web applications that integrate language models, computer vision, voice recognition, and intelligent automation directly into browser and cloud environments. Modern runtimes are evolving to support these demanding workloads with better performance and streamlined deployment. The rise of edge computing is creating another important shift. Traditionally, user requests traveled long distances to centralized servers before receiving a response. Edge computing distributes applications across many smaller locations worldwide, allowing software to respond from servers much closer to the user. Faster execution means quicker websites, smoother applications, and improved experiences for millions of people. Modern JavaScript runtimes are specifically designed to thrive in this distributed environment, making them a key part of the future internet. Of course, the growing number of runtimes also creates challenges. Developers now have more choices than ever before. Each runtime offers different strengths, design philosophies, and performance characteristics. Selecting the right platform depends on the type of application being built, expected traffic, security requirements, and deployment strategy. Fortunately, competition is driving rapid innovation. Instead of one dominant approach, multiple runtime developers are pushing each other to improve performance, simplify workflows, strengthen security, and deliver better tools for programmers around the world. That healthy competition is benefiting the entire JavaScript ecosystem, encouraging faster progress than ever before. The impact of this evolution extends far beyond software developers. Every improvement in JavaScript runtimes helps power the websites, applications, and online services that billions of people use every day. Faster execution means quicker page loads, smoother user experiences, lower infrastructure costs, and more efficient cloud platforms. Even users who have never written a single line of code benefit from these advances without realizing it. Artificial intelligence is expected to accelerate this transformation even further. As AI-generated code becomes more common, developers will spend less time writing repetitive functions and more time designing systems, solving complex problems, and building innovative products. Modern runtimes are evolving alongside this shift, providing the speed and flexibility needed to support increasingly intelligent applications. The future of JavaScript is no longer limited to web browsers. It now extends into cloud computing, edge networks, desktop software, mobile development, IoT devices, and even AI-powered services. What began as a simple scripting language has grown into one of the world's most versatile programming ecosystems. Looking ahead, the pace of innovation shows no signs of slowing down. New runtimes, smarter development tools, and tighter integration with artificial intelligence will continue to reshape how software is built and deployed. Developers will be able to create applications that are faster, more secure, and easier to maintain, while businesses benefit from reduced costs and improved scalability. The JavaScript renaissance isn't simply about keeping an aging language relevant. It's about proving that continuous innovation can transform a decades-old technology into the foundation of modern web development. As the digital world expands, JavaScript's influence is only expected to grow, powering the next generation of applications across virtually every industry.